All right, so what we're going to do today is we're going to take a couple of functions and we're going to make them play nice together. Or at least tolerate playing nice with each other. So we're going to do some operations with functions. So on these, I'm going to give you two equations and we're going to find these operations. And they'll be written like this. We're going to say f plus g of x or f minus g of x. And what this really means, which I need to do that, is if we have a statement that says f plus g of x, what this really means is we're going to take f of x and add g of x. So we can just take the two function rules and add them together. Same thing with the next one. It's very similar. If we're given f of x and g of x and we're asked to subtract them, what that means is we need to take our f of x and we're going to subtract the entirety of our g of x. Similarly, if I have f times g of x, so when they're smashed together, remember that means that they're being multiplied. I wonder what we're going to do with our f of x and our g of x. Multiply them. So our f of x times our g of x. And when we have division f over g of x, we're going to have f of x. And we're going to divide it by g of x. So we're going to start by just doing this with substitution, but we also need to be super duper careful because our domains are going to be a little bit different. Because a lot of times it'll say find the, or perform the operation on the functions and state the domain. So to find the domain of these operations, so I'm just going to write it about all of them. The new domain must be within the domains of both f and g of x. And still hold true. So it has to be true for f, it has to be true for g, and it has to be true of our new function. That's going to be a T. My pen is being a jerk. So particularly with our division here, we are also going to need to be careful that our g of x cannot equal 0 because we can't divide by 0. So we have to be super duper careful with our division one. But there's going to be a lot of times where things, like kind of funky things, come into play. So we're going to start by finding our operations of functions and finding the domains of the new function. So we're going to find all 4 of these with the 2 functions that I give you. Okay? Questions on this part before we start playing with it? Cool, cool. All right, so we're having up here our 2 functions. I've got my f of x equals x squared plus 2, and my g of x is 2x squared plus 1. So first thing I'm going to do is I'm going to think about my domains for f and g. And my iPad is losing its mind. It's frozen. Kind of. There we go. Oh, it's in a mood. There we go. So what is our domain for f? It's a parabola, x squared plus 2. Our domain is going to be all real numbers. How about for g? Again, it's a parabola, so our domain is going to be all real numbers. So that makes it really handy. They match. There's nothing throwing things off. So let's do our first operation and find its domain. So when we have f plus g, and my iPad is freaking out. So my f, I'm going to mark that one as blue, and I'm going to do my green as g. So when we have something like f plus g of x, again, this means f of x plus g of x. So I can write that out. I know what f of x equals. F of x equals x squared plus 2. And we're going to add g of x to x squared plus 1. Can we simplify that? How? 3x squared plus 3. Whoa. So f plus g of x is 3x squared plus 3. And it has a domain. It is also a parabola. And it has to fit inside the domain for the other two pieces. So it has a domain of all real numbers. We'll see some domains that get a little funky in a little bit, I promise. So this one also has a domain of all real numbers. Or from negative infinity to positive infinity. So this is our simplified function. And it has this domain. So those are our two pieces for that first one. Let's do the same with our subtraction. So again, this means we're going to take our f of x, and we're going to subtract our g of x. So my f of x, we know that's my x squared plus 2. And we need to subtract, so we've got to be very careful. I need to subtract everything from g of x. So my 2x squared plus 1, I'm going to put it inside parentheses like this. We need to subtract all of g of x. So when we simplify this, what are we going to wind up with? Yeah, sorry, my brain took a second to process that one. Yes, negative 1x squared or negative x squared. Because x squared minus 2x squared. Oh my gosh. What is going on with my iPad? All right. No, why is that as okay, there we go. Whoa. There we go. That one. So we have our minus x squared. 2 minus 1 gives us minus 1. Oh, positive 1. There we go. Positive 2 minus 1 becomes a positive 1. Yep, nope, call me out on that. So this is our simplified function. The two of you get along, please. Come on. So what is our domain going to be? Yeah, same thing. All real numbers. What the heck is that? Here you go. I love it so much when we work together so nicely. Oh my gosh, we love this. So our domain Where's my rock with that? What the heck is this? Oh my gosh. Oh. I'm gonna try and see if I can switch it back. Will you work now? Will you work now? Yay! You work now. Kind of. Sort of, maybe. Oh, we love technology. It's so much fun. So much fun. Okay. So any questions on our adding or subtracting stuff? I'm fixing this highlight because that is trash. Because that was bothering me. Okay. So then it's the same kind of process for our multiplication and division. I need to take my f of x times my g of x. So this time when we substitute those in, I'm going to put them both in parentheses. Because I need to have my x squared plus 2. And we're going to multiply that against my 2x squared plus 1. And yes, we need to really multiply that out. So what do we get when we multiply this out? Careful, careful. 2x, what exponent? 2x to the 4th. And then we're going to have our plus 4x squared plus 1x squared plus 2. So you can write it out that way. When we simplify that, we can combine together those middle x squareds to have our 2x to the 4th plus 5x squared plus 2. Our domain was real numbers here and real numbers here. What is our domain for a quartic function, for a fourth? What is the domain for any even, stop. Okay, any even polynomial? What's the domain for any polynomial that doesn't have any like denominators or anything? All real numbers. So this one's domain is all real numbers still. It's a fourth. It would be kind of W-shaped, but it's still a polynomial that we could graph that if we wanted to. All right, our last one, probably the most obnoxious, is our division. So when we have it set up like this, we're going to take and we're going to divide our f of x, that's an f, by our g of x. So I'm going to write a big fraction, and I'm going to put my f of x on top, so that's my x squared plus 2, and my g of x goes on the bottom. That's my 2x squared plus 1. Is there anything we can do here to simplify this? Not really. So that's this is our function here. This is, like, that is the simplified version. All we have to do now is find our new domain. Does my numerator do anything weird to my domain? No. Does my denominator do anything weird to my domain? Because what can my denominator never, ever, ever equal? 0. So my iPad is being a jerk. Thank you. Maybe. There we go. So this guy has a domain of all real numbers, so it's really not causing us any problems. But this guy cannot equal 0. So we need to figure out where it does equal 0 so we can kick it out of our domain. So we need to find out where 2x, come on, iPad, 2x squared plus 1 equals 0. Oh my gosh, iPad. Stop losing your dang mind. I love it so much, I wish it would be here. So how do we figure out where this equals 0? Subtract 1, and then divide by 2. So we have our x squared equals negative 1/2. So where does this equal 0? Because if I square root that, what are we going to get? An imaginary. So does this parabola ever equal 0? This gives us imaginary roots. So does it ever have real roots? No. So it never is going to equal 0. So that means our domain for this function is still just going to be all real numbers. Or from negative infinity to positive infinity. So this one, our domain is the same the whole way down. With our division one, we have to check and make sure our denominator doesn't equal 0. I'm going to attempt to highlight all of our answers so that we have them, but my iPad's in a mood, so we shall see. So this is our function here. We hit our domain, and we hit our domain. There we go. Yay! Finally got all the things marked. The iPad was in a mood. Okay, questions on our first set of all these operations? Okay. Because sometimes they don't just give us quadratics. Now I have f of x being the square root of x plus 5, and g of x being the square root of x plus 5. And we're asked to find f times g of x and state its domain. Since we need to find its domain, let's find the domain of f and g. So what is the domain here? With square roots, what does my radicand need to be? Or at least non-negative, right? It can equal 0, but it needs to be 0 or bigger. So when does x plus 5 be equal to 0 or greater than? When x is what? X is greater than or equal to negative 5. So our interval goes from negative 5 to infinity, right? How about for g of x? Same. From negative 5 to infinity. So these are our domains. We'll use those in a little bit. But sometimes it's easier to figure those out before we start doing other pieces than coming back to it at the end and figuring it out then. So now we're going to do our operation. We're going to do our f times g of x. That's the way it'll be written in the book. Which means we're going to take our f of x times our g of x. So when I write this down, my f of x, that's my square root of x plus 5 times square root of x plus 5. If you put them in, you can put them in parentheses if you want, but you don't have to. What do we notice here? What happens when we multiply square root of x plus 5 times square root of x plus 5? This is the same thing as if I wrote the square root of x plus 5, that goes all the way across, squared, right? So what does f times g of x equal? X plus 5. So if we were just looking at this piece, what shape is this? What would this look like? A line. So if I just gave you this equation, what would its domain be? All real numbers. However, we know it came from those guys. So this has to come from these domains. It has to fit inside. So what is our domain of f times g of x? Yes. It has to fit inside these domains. So the domain of our multiplied function here is still going to be our -5 to infinity. It's kind of like when we would do inverse functions and our square roots had this domain restriction because parabolas, if we flip them, are not functions anymore. So we just cut off half of it. So it's very similar to that. It's coming from the same kind of place. So composed functions have the domain of the two pieces it was built from. Don't you blink at me and get grumpy again. Okay. Questions on this one? We're going to do an ucky looking one. So we're going to do f plus g of x, and we're going to do f divided by g of x. For my f of x is 2x over x minus 4, and g of x is x over x plus 5. So let's start with our addition. Actually, let's start with our domain. What is our domain for this one? All real numbers except for 4. So you can write it as all real numbers x not equal to 4. That's our algebraic notation. Otherwise, it's our negative infinity to 4, parentheses, 4 to infinity. How about for my g of x? What's my domain? All real numbers except x can't be -5. So we're figuring out where that denominator equals 0. My numerator can equal 0 totally fine. My denominator cannot equal 0. So let's do our addition and see what happens there. So we're going to take our f of x and we want to add g of x. So that's my f plus g of x. So my f of x is 2x over x minus 4. And we want to add my g of x, which is x over x plus 5. Just scooching that over a little. How do we simplify this? We need to get to a common denominator. So it's not that we're going to do both sides of the equation because we don't really have an equal sign here. We're not going to put it on both sides of the equation. So what are we going to multiply this left one by? What do we need to multiply this guy by? X plus 5 over x plus 5. We can multiply it by a funny looking 1. And my green one, what are we going to multiply it by? X minus 4 over x minus 4. So now we have that common denominator between them. So my denominator is x minus 4, x plus 5. And we are going to multiply out our numerators. So what do we get as our numerator over here? X squared plus 10x plus x squared minus 4x. And we're going to simplify that. So simplified, my numerator is 3x squared plus 6x. We're going to keep our denominators in its factored form, because what we want to do is we want to check and see if anything simplifies. Will anything simplify? I was going to say, we could factor a 3x out of the numerator, and that'll let us see if we have any factors that simplify. So let's factor out the numerator, 3x. What do we get left over when we factor out that 3x? X plus 2. Does anything simplify in our function? No. So what is our domain going to be for this guy? X cannot be 4. X cannot be negative 5. We can see that from here. X can't be 4, X can't be negative 5. And we can see up here, it also is those same values we had in our f of x and our g of x. So they happen to match up, but if we have an excluded value up here that is not included in our new function, it still counts in our domain. We'll see what that looks like, I promise. So our domain is, definitely meant to be domain, is all real numbers except x cannot be 4 or negative 5. So in our interval notation, that's our negative infinity to negative 5, negative 5 to 4, and 4 to infinity. So hopping over negative 5, hopping over positive 4. That's a 4. It looks like a Hebrew letter. Okay, so questions on our addition? It's entirely possible. So let's do our division here. So we're going to take our f over g. That means we're going to put f of x over g of x. So when we build this, we are going to wind up with a monster fraction, because my f of x is 2x over x minus 4, and my g of x is x over x plus 5. And we are dividing these two pieces. So, what can we do here? Multiply by the reciprocal. So we're going to take our 2x over x minus 4. And we are going to keep our top, change the sign so it changes to multiplication, flip the bottom. X plus 5 over x. Remember, when we are working with these rational functions, we're going to keep things in factored form. So when we multiply, what are we going to get? We're going to keep them in factored form. So we just smash together. So my 2x times x plus 5. It's all in factored form. So if we had anything that canceled out, it would show here. X times x minus 4. We just multiply across. So if we were just looking at this function, what would our domain be? What are our excluded values? X cannot equal 4, and x cannot equal 0. So if we were just looking at our new function, that would be our domain. However, we have to remember it came from this one where x cannot equal 4, so that one's covered, and it came from this one where x cannot equal -5. So we have to take this and include it in our domain. So if there are pieces that are not in where it came from, they're not from its homeland, we have to include it. So, and x cannot equal -5. That is coming from, I'm just going to highlight it. This piece is coming from the fact that g cannot equal -5. So it has to be included in there. So our domain is going to go from, I'm just trying to fix right up, -infinity to -5, -5 to 0, 0 to 4, and 4 to infinity. So interval notation, they get gross. It's hopping over those excluded values. Where'd I lose you? I was going to say, unfortunately, I'm lost. Just doesn't give me enough information to figure out where. Yes, sir. You can. There's nothing wrong with multiplying it out. 2x squared plus 10x over x squared minus 4x. Nothing's going to cancel out because we'd have to refactor it to cancel things out anyway. It's not wrong to multiply it out. We just usually leave things in factored form anyway. What's up?
So when you do the domain, you have to put little r and the x.
Yes. So putting it algebraically, you can just put the real, like the all real numbers, and then x not equal to these values. And when you're looking at like your original functions, it's easy to do it that way because that helps you figure out your intervals. You do want to state our like combined function as intervals. And I know they're a mess, but that's how we're supposed to do it. Okay. Questions on this one, because I know it's a lot. Sometimes they'll be like this, where it's x's and super gross. Sometimes they're going to give you numbers. So I'm going to, just making a change real quick. Sometimes we'll get things like this. Find f minus g of 2 and f times g of 2. So they give us our f of x and our g of x. So these are evaluating, just kind of in the extreme. So we are asked to find f minus g of 2. So what that tells me is we need to do f of 2, and we're going to subtract g of 2. So you can either set it up as f of x minus g of x and like do the whole thing and simplify it, or we can just like evaluate it there. Because what is f of 2 going to equal? Yeah, because we put a 2 in here and place this x, so 2 squared is 4 times -1 is -4. So -4. What is g of 2 going to equal? We're going to put 2 in here and place this x. 2 times 2 minus 1. 3. So evaluate it in each of those places. So then we're left with -4 minus 3. What's -4 minus 3? -7. So we could write this whole statement as f minus g of 2 equals -7. It equals -7. It just does. It's a number, not a function. It's just a number. And then it's very, very similar for our f times g of 2. This is f of 2 times g of 2. So what is f of 2? Negative 4. What is g of 2? Not negative 3. Just 3. What is negative 4 times 3? Negative 12. So our f times g of 2 equals negative 12. So you can take and evaluate it at the numbers and just make your life a whole lot easier when you're doing values like this. One more set, okay? And we're just doing it with numbers. But we're going to hit all of them. So just fixing because it had a weird piece on here. There we go. So we've got f of x as x plus 3. G of x is x squared. We're going to do f plus g of 3, f minus g of 3, f times g of 3, and f divided by g of 3. So all of these are evaluating at 3. So let's find out what is f of 3. Six. What is g of 3? 9. So when we're looking at f plus g of 3, we're going to take our f of 3, which is 6, plus our g of 3, which is 9. So it's going to equal 15. When we do f minus g of 3, that's going to be our 6 minus our 9. And we're going to get negative 3. How about f times g?
45. 54.
That's going to be our 6, wrong color. Our 6 times our 9, which gives us 54. And then our f divided by g of 3, 6 divided by 9. You jumped a little too fast. 2/3. Okay, so evaluating them at numbers is very, very straightforward as long as we understand what's happening. Okay? So questions on this part. We have one more bit of 3.7, which is stuff that you've seen before, but we're going to go through it again because we haven't done it with quite these functions. I'm going to show you just so we see it. Composition. You guys have seen these. You did these in algebra 2 where we have our f of g of x, g of f of x, these guys. So that's what we're going to work on next time. So our 3.7 homework is currently due, it says it's due on Wednesday. I'm going to move that to Friday simply because I'm letting you guys know I will not be here tomorrow. So we are going to finish 3.7 on Wednesday. So tomorrow what you guys are going to do is you're going to start working through that review packet so that you guys have time. You can work on it. I have videos that go through literally every single question. And the answer key are already up on Canvas, so you guys can work through those. And tomorrow, when there's substitute, you can have like work together as long as being polite and that kind of stuff. That's a sub too. But then Wednesday we will finish up with the composition stuff. Thursday's e-learning. Friday's the test. Okay, that's kind of the vibe for the week. So I'm gonna change this up here.
Fell asleep 15 times. Yeah, I saw you fall asleep and I was about to text Justin to wake you up, but then you woke up.
4. I'll post the answer key of it before then, but I'm just going to say not due till Friday because that's the next time I'll see you after we finish the 3.7.
This is the muscle day. This muscle